Hi guys, so today we're going to be looking at Chapter 4, Section 4, Factoring Polynomials. We're going to first start off with factoring by grouping. So, for factoring by grouping, let's say we have the example, factor z to the power 3 plus 5z to the power 2 minus 4z minus 20 completely. If I'm going to do this, I'm going to start off first by taking the first two terms and trying to factor out a number from those two terms and do the same thing with the 4z minus 20. So right here I'll just write down the expression z to the power 3 plus 5z to the power 2 minus 4z minus 20. And then from here, for the first two terms, I'm going to identify a number or a variable that I could divide to both of them. I can see here that I could divide z to the power 2 by both of them. If I do that, I'm going to take the z to the power 2 on the outside, leave it there, and I'm going to be left with z plus 5. And then for the other two terms, I have here negative 4z and negative 20. Both of them can be divided by negative 4, so I'll take out a negative 4 from both. When I take out negative 4, I'm left with z plus 5. And so from here, you can see that we get the same factor that I can combine together. So I'll combine the z plus 5 together, and my leftovers, which is the z to the power 2 and the negative 4, are going to be its own factor, z squared minus 4. Now, it seems like we're done, but we aren't, because of the fact that we could still factor out z to the power 2 minus 4. And this is by using one of the special factors. And you learned this one in Algebra 1. So I'll write down this is Algebra 1 review. This was one of the special factors. And the formula was, if you're able to see that you can square root two terms, then they can split off into two different factors, where one of them is going to be a minus b, the other one is going to be adding the terms instead, a plus b. So from here, if you can see that for both terms, for example, the z squared and the 4, they're both like able to square root, which it seems possible for me to square root both of them. Then that means that we can use the formula a squared minus b squared. So our a value would be the z squared, and our b squared would be the 4. So from here, to get rid of these squares, I'm just going to square root to both of them. Same thing to the b and to the 4. And when I do that, I'm left with a equaling to z and b equaling to 2. So our new formula here would be using the a minus b and the a plus b. So we get z minus 2 and z plus 2. And I'm just dropping down my z plus 5. Now I see that there's nothing else that I have to square root, so I can continue on with the next question because I completely factored out the expression. Alright, next one is factoring polynomials in quadratic forms. So if I'm going to factor a polynomial completely, let's try out this one first. We have here 16 times x to the power 4 minus 81. If I'm going to factor this out, I can again use that special formula a squared minus b squared, where when we factor it, the first term is going to be subtracting with the second term and also adding with the second term. So to do this, it's a little bit bigger, but that's okay. We'll still go through the same steps. We know that our a squared is supposed to be the first term, which over here we have 16x to the power of 4. And for our b value, our b squared is supposed to be 81. So if that's the case, I need to figure out what my a value is and my b value is. So I'll square root on both sides. So I'm square rooting to both sides. And so right here, after you square root it, then we can figure out our answer. With the 16x to the power 4, I can expand it. So that's 4 times x to the power 2 times x to the power of 2. Because we know that x to the power 2 times x to the power 2, that equals to x to the power 4. And so, again, whenever you're square rooting, you have to take out a group of 2's. So I could take out a group of 4's out from the square root. I can also take out the group of x to the power 2's from the square root. On the other side, this just becomes b equaling to 9. And so I can finally write my new factor, which is 4x to the power of 2 minus 9 and 4x to the power 2 plus 9. Now the important part is not to stop there, because of the fact that we need to check to make sure everything is not square rootable, especially if you still have a negative sign in between two terms. So I don't really have to look at this one here because of the fact that it's positive, so I could just ignore it for now. But I do have a negative sign here, so I want to see if these two terms are square rootable. If they are, then we can continue on with using the special factor, using the a squared minus b squared. And so if that's the case, then I get here a squared equaling to 4x to the power of 2 and b squared, and let me make it bigger, b squared equaling to 9. And if I were to square root it for both, same thing with the b, we get here a equaling to 2x and b equaling to 3. So our new term is going to be 2x minus 3 and 2x plus 3. Then don't forget to also drop down your original factor, which was that 4x squared plus 9. And that would be my final answer. Let's try out one more problem. This one we're factoring out completely. 3p to the power of 8 plus 15p to the power of 5 plus 18p to the power of 2. So for this one, if you have here 3p to the power of 8 plus 15p to the power of 5 plus 18p to the power of 2, I'm going to start off first by seeing if there's anything that I could divide to all three. And I could see here that I could probably take out a 3p to the power of 2 from every single term. When I do that, I have here 3p to the power of 2, and this becomes p to the power of 6 plus 5p to the power of 3 plus 6. And that would be your next factor. Then, normally, if you see something like this where it seems pretty big, you can kind of assume that there's possibility of being able to factor still. So I'll use the box method. We have here p to the power 6 plus 5p to the power 3 and 6. And you can use either the cross method or the box method. I'm going to use the box method because just want to use it. So right here we have p to the power 3 and p to the power 3, I know that p to the power 3 times p to the power 3 equals to p to the power 6. And two numbers that multiply to get 6 are 3 and 2. And so if I were to multiply these across, so I would get here 2 times p to the power 3, which is 2p to the power 3, and 3p to the power 3. When I combine those two together, I'm left with 5p to the power 3, which is my middle answer. So I do know that these factors over here are going to work out for sure. So right here, I get p to the power 3 plus 3 times p to the power 3 plus 2. And I'm just going to drop out down that p to the power of, or 3 times p to the power 2. And that would be my final answer. So hopefully this helps. Good luck.